Okay, before going to the next tutorial, don't forget to reconnect this to this. And again, the way you can do that is just click on here and then click on here. Okay, let's go to the next tutorial. Okay, so this is again 1 through 5, and it says let's do some data science. So in the last tutorial, we loaded a data set and we ran a process. We found that 349 passengers survived the Titanic accident. Let's build a process to see if those survivors have something in common or not. So before we do that, let's just look at the data again. Remember, we had some people that survive and some people that don't. And then we have a bunch of other information about each passenger. Like here's the first passenger. They did survive. Their age was 29. They were in first class and a female and so on. So we have some other data about this, in fact, about all of these passengers. So we might be interested in what factors or what was common to the passengers that survived, what was common about the passengers that didn't survive. So we have a rather large data set here, and to try and figure that out by hand would be pretty difficult. But maybe we can employ RapidMiner and some of the data science tools within it to get this kind of information. Let's go back to here and go to the next part. Okay, load the Titanic training data again. So let's go back and practice this again. So we go to the, remember this is the repository. This is sort of the file explorer. This is where we can find different folders and directories and files on our computer. And there's apparently a folder called samples installed in your computer somewhere. And within there, there's another folder called data. So we want to reload the same data. And this, remember, was called Titanic training. In fact, there were 3 different kinds of Titanic, this one, and this one. Anyway, they just want us to load this one. By the way, you get this if you just put the pointer on there, you get some sort of information about what's in this data set. In particular, you get the fact that the variable names are age, passenger class, and so on. You also get the type of data and sort of information about what the data looks like here. So this says that the age ranges from is basically 0 or less, not anyway, less than 1 year, I guess, and less than or equal to 80 years old. So here we get to see if we can remember how to load this data. So remember that we can click on it and I guess just drag it here. And there, so we've started loading it now. And they said drag the Titanic training data from the samples, which is here, into the process panel. So this is one of the panels. It's called the process panel. So let's read the explanation. You have defined the first operation of your process. So remember, these are called operators. So they say we've defined the first operation of our process. Now we will learn how easy it is to build a machine learning model on this data. Okay, so let's go to next. And this is 3. Build a decision tree. So this machine learning algorithm is called a decision tree. So there are many different machine learning algorithms that we could try, and this is one of them. So anyway, let's see how we do it. So anyway, they say that the decision trees are a popular statistical modeling technique that finds hidden patterns in the data. Let's build one. So they tell us to find the operators panel, which is here on the left, and open the folder Modeling, Predictive, and finally Trees. So I have some operators open from before, data access type of operators, but I'll just, let's see, cancel this so we can see all of them. So these different operators are stored here, and they put them in folders, sort of like just to keep them organized. So some are called data access, so they put them in, are kind of for accessing data, so they put them in a folder called data access. And there's another one called blending, they put it in a folder called blending. And there are other types. So anyway, they said to go to the modeling, so that's here, and predictive, and finally trees. So within modeling, we have all of these different types, and here's one called predictive, and then we go to trees, and drag in the decision tree operator, and drop it in the retrieve, and drop it after retrieve Titanic training. So after this, we just want to find it and drop it here. So it's called decision tree, which is the first one, and just drag it to here. Okay, let's read the explanation. Good, we now have the operator in the process, but we still need to connect the two operators and define what we want to see as the output before we can run it. Okay, let's see what that means. So this so-called decision tree operator will build a decision tree, whatever that means, for us based on our Titanic training data. We still need to connect these operators together to build a process, though. We still have to connect this stuff and connect this to here. So we're not really explaining very clearly what these ports are, but they're just telling us what we should do. They haven't really explained what exactly a port called tra means. It actually means training, but what does that mean? They haven't explained what these port names mean, but they're just telling us what to do. So we want to connect the retrieve Titanic training with the input port tra. We want to connect here. You can click on the ports, or you can drag on them. So I guess we could drag it, or we could click. So I'll just drag it this time. Last time we clicked, and there. Now we have the so-called connection. Now it says connect the first output. So we have some outputs over here, and I guess this is the first one, called mod, which probably stands for model. So we want to connect that with the result port res on the right side. So we want to connect from here to here. Again, we can drag it, or we can click and then click. I guess it's the same thing. Okay, now apparently that's enough to run this now. So we can press the run button up here to execute the process. Let's try it. Okay, so this is the result, and we can see up here we're in the result, and we can see up here we're in the result, and it's somewhere over here. Maybe we could zoom out, because it doesn't seem like we're looking at the entire picture here. Okay, maybe we should slide this over, and I guess we have to make it even smaller. A little bit hard to read now. So let's see what they said. The decision tree operator, remember we had the decision tree operator here, will build a decision tree for us based on our Titanic data. We still need to connect these operators together to build a process, though. Sorry, great job. Your process should now be complete and deliver a decision tree model which explains to you what most of the survivors and most of the victims had in common. Read more explanation on operator ports and decision trees here. So let's see what kind of information we can see in this decision tree. Let me make it bigger. It's a little bit hard to read. So we can see that this tree has what we call a top node here, the top of the tree. And we can see that there's a line extending from here and here, And this line, well, sorry, the name of this is sex. And remember that sex has two different possibilities, female and male. So we can follow this out. So we could go here, female. And so it means if the sex is female. And then there's another, what we call a node here. And you can see that, well, anyway, the number of parents or children on board. So if the number of parents or children on board is less than 4.5, I just moved it over. So if it's less than 4.5, we go this way. And if there should be a line here, but it's not very bright. But if it's greater than 4.5, then we go this way. So this way brings us to no. In other words, they won't survive. So if the number of parents or children on board was greater than 4.5, that means that then this tree or this model predicts that they won't survive. So maybe we can say that if they have too many people to take care of, they're gonna have trouble. They're not going to survive. Okay, so that's one conclusion that we can see by way of this tree. Now we can also follow down here. We said if the number of parents or children on board was less than 4.5, then this tree says, okay, check the number of siblings or spouses on board. Okay, and if that is greater than 4.5, then it will this model, this tree, will also predict no. On the other hand, if it's less than 4.5, then the tree says check the passenger fare. And if the passenger fare is greater than this amount, then the tree predicts that they will survive. And if it's less than this, then it says check something else. So that's the way you read the tree. You can see that each pathway ends with one of these. In other words, it ends with a prediction about whether they will survive or not. And that's true for the entire tree. On this side, remember, we could have gone male and checked these. Okay, so that's our first model, our first data science model. And you can see that this gives you a lot of useful information that probably would be pretty difficult for you to come up with just by perusing the original data. Okay, let's continue. Let's go to the next part of the tutorial.